Hello everyone, welcome to the World of Chemistry YouTube channel. Today I'm going to discuss the very most important chapter in chemistry, that is structure of atom. Everything around us, including our body, air, water, plants and stars, is made up of atoms. But have you ever wondered what atoms look like? Is it really the smallest particle of matter? How electrons are arranged? How electrons are arranged inside an atom? Hmm? So, scientists spent many years trying to answer these questions. So, in this chapter, we will explore the fascinating world inside an atom and understand its structure, properties, and behavior. So, before we start a main topic, let me ask you some questions. What is the smallest particle of matter? So, as we have studied structure of matter in the earlier classes in the school level, so I am asking you some very simple questions. Okay, what is the smallest particle of matter? Who proposed? Okay, who proposed first atomic theory? Can we see atom with our eyes, or what particle are present inside an atom? Okay, so let me know about these answers. So before understanding the structure of atom, let's first recall what atoms are and how scientists discovered that atoms themselves are made up of smaller particles. So that leads us to the some interesting theories. The first one is Dalton atomic theory. Then we'll discuss discovery of electron, discovery of proton and neutron, atomic number and mass number, electromagnetic radiation and spectra, Bohr model, quantum mechanical model. Okay, if consider an atom enlarged to a if an atom is enlarged, consider this is the cricket stadium. Okay, so the nucleus would be only about the size of marble at the center. Marble at the center. So while electrons are moving around it, this shows how empty space exists inside an atom. So we can imagine a cricket stadium. It will be very big, big, big. So the one small marble, or we can say a batting pitch, so that is only the center. So everything is the around that is empty space. So this is how the atom exists there. Okay, so next we'll see how the theory goes. Earlier, Indian and Greek philosophers said that so the atoms are building atoms are building blocks of matter. They said the atoms are building blocks of matter. Okay, so this was said by the Indian and Greek philosopher. So according to them, they continue to tell us that the atom is indivisible. They said that atom is indivisible. indivisible, and uncuttable or uncuttable. So the earlier ideas were only the speculations. There were no exact theory behind it to prove that the atom is indivisible or it is uncuttable. So what happened next is what happened next is they said that the one second the so this is the matter. So they said it is made up of atoms. So atoms are the building blocks of matter. Okay. Then the atoms was derived from the Greek word that is atomio. That means it is indivisible. Okay. That is indivisible. So next, the some atomic theory of matter was first proposed on a scientific form on the basis of John Dalton. He is the British school teacher. He was in 1808. So then it is called the Dalton atomic theory. It's called the Dalton atomic theory. Dalton atomic theory. Then, so atom as the ultimate particle of matter. But Dalton's atomic theory was able to explain some laws. Okay, they were able to explain some laws. They are law of conservation of mass, the law of constant composition, and the law of multiple proportion. Okay, the law of multiple proportion. They explain them very successfully. So however, then it is failed to explain the results of many experiments. For example, it was known that a substance like a glass or ebonite, when rubbed with a silk, it get electrically charged. So they fail to explain that. So now in this chapter we will discuss some experimental observations made by the scientists at the end of 19th century and the beginning of 20th century, how atoms are made up of subatomic particles, that is electrons, neutrons, and protons. So this concept is very different from the Dalton atomic theory. Okay. So what Dalton assumption were that atoms are indivisible. The concept was very wrong. So then it is proved that the atom can be divided into electrons, protons, and neutrons. Okay. Now see how the discovery of subatomic particle took place. So here we'll learn discovery of electron and discovery of proton and neutron. So let's discuss how the discovery of electrons took place. As we all know, like charges repel each other and unlike charges attract each other. So this is the very basic concept. Okay. Next, what happened during the discovery of electron? The Michael Faraday showed that the electricity is passed through a solution of an electrolyte. So the chemical reactions occurred at the electrodes. Okay. Then in the mid of 1850s, scientists mainly the Faraday began to study the electric discharge. So it is partially evacuated tubes known as cathode ray tube. So this is the how the experimental setup is made. Okay. So this is the experimental setup of cathode ray discharge tube. So now we'll see how this cathode ray discharge tube works. So here is this is the vacuum. Here is the two electrodes. Inside that there is a very low pressure gas, low pressure gas. Okay. So here across the two electrodes there is a high voltage current is applied. High voltage current is applied. Okay. Here we'll discuss again. Okay. Now, so the two electrodes, one is the cathode that is negatively charged and one is the anode that is positively charged. And this is the vacuum pump and we have very high voltage battery. Okay. These are the cathode rays moving from cathode to the anode. Okay. The rays are originated from the cathode. So that's why they are called as a cathode ray discharge tube. Cathode ray discharge tube. So to observe the rays, so we have to make sure that there is a very low pressure of gas inside the tube and very high voltage of current is supplied to the electrodes. So the as we can see the current starts flowing through the stream of particles moving in the tube from negative electrode to the positive electrode. So this is called as a cathode rays or cathode ray particles. The flow of current from the cathode to anode was further checked by making the hole in the anode. Making hole in the anode. So J.J. Thomson made some modifications. That is the a complete evacuate and hole was created in the anode. So then the zinc sulfide screen was placed behind the anode to see the rays. So the cathode rays were so fast that we can't see it from the naked eyes. So to see them, how we can see that means there is a some fluorescent material behind it. So when it start in a straight flow from negative end to the positive end, we can the blink the this fluorescent screen will start shining. So from that we can see the energy and they are moving in a straight line. Okay. So the flow of current from the cathode to anode was further checked by the making hole in the anode, then a coating the tube behind the anode with a phosphorescent material. Okay, that is zinc sulfide. When these rays after passing through anode from cathode to anode, after passing through the anode strike the zinc sulfide coating, they'll come and hit here with a zinc sulfide coating and the bright spot developed on the coating. Here the bright spot is developed. So what observations here we can see that so this is the experiment setup. We can see cathode rays move from the cathode to anode. So cathode rays are invisible. Okay. So these travel in a straight line. In presence of electric field and magnetic field, it deflect towards the positive plate. So here we can see it is deflecting. to the positive plate. Okay, so the characteristics of cathode rays is independent of material of electrodes or nature of gas. It is only dependent on the low pressure of the gas and the uh, high voltage electricity should be applied. So as the rays were originated from the negative terminal of the tube, or the electrode, that's why they are called negative charge particle, or then they named it as a electron. So these are the some observations they made. In the presence of electric or magnetic field, the behavior of cathode rays are similar to that of expected from negatively charged particles. So in that sense, cathode rays consist of negatively charged particles. So that's why they are called as a electrons. So these cathode rays do not depend on the material of electrode used or the nature of gas present in it. So this is how we can conclude that electrons are the basic constituent of all the atoms. Okay. J.J. Thomson made some observations again. So this is the where inside the anode the hole was created. Okay, the hole was created. This is the fluorescent screen. When the rays starts from cathode to anode, pass through the anode, and through that hole they'll hit this fluorescent screen. So this is the magnet, north pole and south pole. Here the very high voltage electricity is applied. So what deflection, how the deflection depends on what criteria it depends on, means it depends on the mass of the electron, it depends on the charge of electron and the strength of the field. Okay, so this is the setup. Electric force, magnetic force, that must be the static. Then we can see here is E by M ratio. So that value is 1.758820 into 10 to the power of 11 coulomb kg per gram. So E is the charge of the electron, that is negative, and M is the mass of electron. So Mulliken oil drop method we'll see in the next class. Thank you for your patience and watching this video. Please subscribe for more concepts related to the chemistry.